Hi, my name is Trevor Dean, and today I'm going to be talking about particle separation. So the question I want you to kind of think about today is, if you were asked to separate a rock into its basic elements, what would you do? How would you do it? How would you separate the iron in the rock, the copper in the rock, basic elements like silicon and things? How would you separate it into different categories? Because this is a question that's been asked by mining and environmental engineers for a long time. Since we first started learning that we could get metals from rocks, the question has always been, how can we improve that? How can we get more? How can we waste less? And today I'm going to talk kind of about one of our current methods that we use a lot in particle separation. So the original way we were able to separate metals from rock is by smelting. What smelting does is you raise the temperature of the rock to really, really high temperature in the thousands and thousands of degrees Fahrenheit. And with that, it separates into liquid and by density. So you'll have maybe like, oh, here's really light stuff like silicon on top, and then copper, and then iron and things. The problem with that, though, in modern industry is to raise things to those heights, the temperatures, it's very, very expensive. And you have a lot of energy waste going out the sides. And so today we're going to talk about a different process that's a lot more lower energy and better for the environment. So the new way we use to separate ore is more efficient, cheap, and effective. And that's what we need to do for it to be profitable for today's industries. So what we do to ore nowadays is, first thing we do is, once we have these rocks that we get after they've been pulled out of the mines, first thing we do is we grind them. And we do a lot of grinding. We take rocks that are maybe the size of your hand or your head, and we reduce them to particles that are less than the width of your hair, microns in size. This allows for all those different particles to be separate, so your copper ore isn't connected to your silicon or your iron anymore. It's its own thing. And that allows us to physically be able to separate it. But we still have it in kind of this big mixture. So what we do from it there is we do a process that separates them, and then during all these processes we add water. We need to take the water out so we can give whoever we need and ask for this product just the ore they ask for. So that first thing is called, that we do, is grinding. That's what separates the particles away from each other. In the picture to the right, you'll see ball mills. They're very large rotating drums with all that ore in it, and allows for the ore to get raised up and then gravity to bring it down and just smash it to pieces into those different smaller sizes. And we want this because we want those minerals that we want to be exposed, because the next process that we're going to use involves chemicals that need to touch those particles. And that process is called flotation. Flotation, what we do is we add specific chemicals that are soaps. And a soap is a long molecule that one side is really hydrophilic, meaning it really likes water, and one side is hydrophobic, so it means it really doesn't like water. And what happens is if we're targeting copper minerals, those hydro parts that really like water attach to that copper, and all these other minerals back, and so it makes like a little bubble around it, and then once we add air into these big cylinders that have all this water and soapy copper, those minerals grab onto those air and they rise to the surface. Even though they're denser than water, they're still able to rise because they don't really want to be touching the water. They want to be touching this air that's going up, and they're so small that they can do that. And then we can scrape those bubbles off the surface and collect that copper. But we still have a lot of water in the system that we need to reduce. Because those particles are so small, things like evaporation would take so long, and for them to settle on their own, it would just take too long. That is not very economical for the company. So we add another chemical called flocculants, which are even longer chain than those soap bubbles, and they kind of act like a little lasso that grabs all these different microscopic particles and binds them together so that they can sink faster. And we're going to show you a video of how they look like in use. So if you look on the right, this chemical, or these minerals have been treated with a flocka, and you can see how they look much more grainy as they settle down. But this makes the process of separating the water from the minerals so much faster. As you can see, it's a visible process, as opposed to the one on the left where it doesn't have flockas. Now, the particles were the same size originally, but they've gotten so much bigger, so much faster. And that saves a lot of time during our processes and allows for a lot more money to be made. So why is this important for us? One, this new method, as opposed to smelting, saves so much money for companies. Because it can all be at the same temperature, you're really just paying for electricity to turn the machines, as opposed to having to burn coal or something to get all this heat and power. Second, it's much better for the environment. A lot of times when you're smelting, you're really only targeting one material. So certain things can escape off as gases because it gets so hot, and you don't want all those bad gases going up into the air. And doing this, having a higher concentrate, greatly reduces all those excess gases. And it also allows us to work in bigger numbers because it's so much faster at separating material than smelting. It allows us to have a lot more of those materials that we need for day-to-day life. So I'd like to open up this last part for any questions, if anyone would like to ask anything.